Georges Lemaître, a brilliant Belgian physicist and Catholic priest, dared to explore the ultimate origins of our universe, presenting a vision so revolutionary that it would change our understanding of cosmology forever. His theory of the primeval atom, an idea that would later inspire the Big Bang Theory, offered a profound insight into the nature of the cosmos, blending science, mathematics, and philosophy in a way that captured the imagination of his peers. In the early 20th century, our understanding of the universe was undergoing a dramatic transformation. Albert Einstein's theory of general relativity had redefined gravity, revealing that massive objects bend the fabric of space-time. Observations by astronomers like Edwin Hubble showed that galaxies were not static, but moving away from each other, suggesting that the universe itself was expanding. While Einstein initially resisted the implications of an expanding cosmos, preferring a static model, Lemaître was among the first to embrace the idea and take it to its logical conclusion. Lemaître's journey began with his studies in physics and mathematics. After earning a doctorate in physics in Belgium, he studied at the University of Cambridge and later at MIT, immersing himself in cutting-edge research. His curiosity was insatiable, and his faith did not hinder his scientific pursuits. Instead, it fueled his desire to understand the natural world. Lemaître believed that exploring the cosmos was a way to glimpse the divine order of creation, though he always maintained a clear distinction between his scientific and theological work. In 1927, Lemaître published a groundbreaking paper proposing that the universe was not static, but expanding, as described by Einstein's equations. He suggested that the recession of galaxies observed by Hubble was a direct consequence of this expansion. But Lemaître went further. If the universe is expanding now, he reasoned, it must have been smaller in the past. Tracing this expansion backward in time, he imagined a moment when all matter and energy in the universe were concentrated into a single, incredibly dense point. He called this the primeval atom, or cosmic egg, a seed of unimaginable potential that exploded to give birth to the universe as we know it. Lemaître's cosmic egg was a bold and imaginative concept. He envisioned it as a fireworks display, with the fragments of the explosion becoming the galaxies, stars, and planets. This idea was revolutionary because it suggested that the universe had a beginning, a finite point in time, when it emerged from this primordial state. It challenged the prevailing view of an eternal, unchanging cosmos and invited scientists to think about the origins of time, space, and matter in entirely new ways. Lemaître's work initially faced skepticism. Many scientists were reluctant to accept the idea of a universe with a beginning, as it seemed to align too closely with religious creation stories. Even Einstein dismissed Lemaître's theory at first, reportedly calling it too beautiful to be true and accusing him of mixing science with theology. But Lemaître persisted, refining his calculations and engaging in thoughtful dialogue with his critics. Over time, evidence began to accumulate in his favor. One of the most compelling pieces of evidence came in 1929, when Edwin Hubble published his observations showing that galaxies were indeed moving away from each other, with their velocities proportional to their distances. This discovery, now known as Hubble's law, provided strong support for Lemaître's expanding universe. In fact, Lemaître had derived the same relationship 2 years earlier, but his work had been overlooked because it was published in a relatively obscure Belgian journal. An intriguing anecdote about Lemaître's interactions with Einstein illustrates the dramatic shift in attitudes toward his ideas. In 1933, the two attended a conference in California where Lemaître presented his theory. Afterward, Einstein reportedly stood up and declared, "This is the most beautiful and satisfactory explanation of creation to which I have ever listened." This moment marked a turning point in the scientific community's acceptance of the primeval atom. While Lemaître laid the theoretical groundwork, it would take decades for his ideas to be fully validated. In 1948, physicist Georges Lemaître and his colleagues developed the concept further, introducing the idea of nucleosynthesis, the process by which light elements were formed in the early universe. Then, in 1965, Arno Penzias and Robert Wilson discovered the cosmic microwave background radiation, a faint glow permeating the universe that served as the echo of the Big Bang. This discovery provided the smoking gun for Lemaître's theory, confirming that the universe had indeed originated from a hot, dense state. Despite the triumph of his ideas, Lemaître remained humble. He avoided the spotlight and preferred to focus on his research and teaching. He saw no conflict between his scientific work and his faith, famously stating that the Bible teaches us how to go to heaven, not how the heavens go. This perspective allowed him to navigate the complex interplay between science and religion with grace and clarity. Lemaître's primeval atom theory not only transformed our understanding of the universe, but also inspired profound philosophical questions. If the universe had a beginning, what came before it? What caused the cosmic egg to burst? While science may never fully answer these questions, Lemaître's work invites us to ponder the mysteries of existence and our place in the cosmos. Today, Georges Lemaître is rightly celebrated as the father of the Big Bang theory. His vision of the primeval atom was a testament to the power of human imagination and curiosity. By daring to look beyond the observable universe and into its origins, Lemaître opened a window into the profound beauty and complexity of creation. His legacy reminds us that the pursuit of knowledge is a journey without end, one that continually challenges us to expand our horizons and seek deeper truths about the nature of reality.